I think. Oh,
sorry, everyone. I forgot to record. And Melissa, thank you for reminding me. I was having so much fun with you before, Matt, so I didn't mean to freak you out. But
no worries. We will just reiterate for the record here that
yeah.
TypeScript is JavaScript with syntax for types. That's basically it. Yeah. All right. Moving on. Why or why not use it? So you'll see the lists are fairly balanced, but I think in most cases the pros will outweigh the cons. I do want to touch on them though. I think the most important decision for either an individual or an organization when choosing whether or not to use TypeScript are these first pros and cons here. Catch and fix problems sooner, and the con being the initial investment or the learning curve. So basically, like, no matter what you're doing in software, you're trying to do things in some respect, you're trying to get things done faster. You're trying to build things more quickly. And so, build good things more quickly, things that don't break. So if you can catch problems, bugs, null reference errors, things sooner than with types than if you were to catch them without types, and you can do that at a rate that's greater than the cost of the initial investment of like putting it in your package, configuring it, and all this, then that's a win. And I think in most cases, that's going to be true. There is an initial investment though, because you are writing more code up front. You're adding types for basically everything that you are, for every variable, for every function, everything that you write has to have some extra code attached to it, and that has a cost. It's not a great cost, but over the course of your entire application, adding types to every single thing can be costly. There are some conveniences built into TypeScript to hopefully help reduce that cost. And I don't think I really have to speak to the pro too much, but basically, TypeScript will show you type errors in your code before runtime. So something that you would build successfully and it would run, but then it would error and your app would blow up. You've now wasted that time, building the application that you could have caught that error with TypeScript before doing so. So that TypeScript in that situation would save you 10, 15 seconds, whatever. Over all the different like null reference errors and just misunderstanding of data, it depends on your situation, but I feel more times than not, being able to find these things more quickly is going to mount to a larger time savings than the cost to learn it or implement it. Another big pro, I'll just try to kind of go one by one, pros and cons, just to try to give a balanced approach here. Great IDE and package support. So like one of my favorite things about TypeScript is the IntelliSense that comes with it. So like if you have types or like models built out for your data and you are starting to write things for that data, your IDE will be able to autocomplete properties of your typed objects because you've told the IDE what properties that type has. So you can save little bits of time there because you won't have typos because you're auto completing it. So you won't spend 15, 20 minutes trying to like track down a typo in a variable name because you've auto completed it. Doesn't sound like a huge deal, but I think it really is. Autocomplete is such a useful utility. Beyond that, package support, like I don't just mean that popular packages have type declarations. A lot of them do, but they're also really neat integrations with different modules and packages. Like one of my favorites is Storybook. So like if you use TypeScript with Storybook, you can like within the interface that Storybook provides, it will like document the types for you. So if you have to like send this to a different team or a marketing team or something, like all the type stuff's all just documented for you. There are a lot of other cool integrations, like GraphQL has some cool TypeScript integrations where like your GraphQL schema can match up to your TypeScript models and so forth. And there's a lot of really neat opportunities there. But I could go on and on, but those are just a couple of my favorite examples. So I'll jump to a con. Like, let's say you are just building a greenfield application. You don't know what the data looks like. Like, having strong types, if you don't know what the types are, isn't going to be super useful to you. Because if you change the data all the time, then you're gonna have to change the types all the time. And now you're like doing double the amount of work. So, if that's the case, that might be something to consider. For like a brand new app, or an app that's like getting like a huge API overhaul or something like that, it can be a pain in your butt. There are some ways to get around that. There's like the any type, which basically is just like I'll do this later. It's like a to-do type, or just like I actually don't know, or I'm really lazy and I don't want to type this right now, which is a problem, but that's a problem with your team, not with the tools. It's self-documenting, by which I mean you have the types written in the code already. So instead of having to write comments that is like this function, like if you remember the old JS docs syntax, you would like add in the parameters for the function and what those types of those parameters are and what the function returns. But like with TypeScript, that just happens as part of the code. It's like a requirement. You have to tell, whoever's looking at the code what type of data has to go in there and what type of data comes out. So the problem solves itself. You don't need JS docs. You don't need to manually, figure stuff out through comments. It's just all right there, which is great. And then, some people don't leave comments. They just like make sloppy code. But with TypeScript, they have to make good code. It kind of forces good behavior, which is always a good thing in my opinion.
Yeah, so someone just mentioned that this could be confusing for some JavaScript developers, like interface or generics, tuple, etc., if you're not exposed to C++ or Java kind of languages. So just kind of a comment. That was good.
Yeah, so TypeScript does a couple of neat things to not require a person to understand those more complicated non-JavaScript types. I'll get into that a little later.
Okay, cool.
Yeah, but yeah, higher cognitive load, that's the con. So you do need to know more syntax. You do need to look at more code to understand it. Like, you don't have the option to just visually ignore it. There are ways to organize your code where you can like export the types into a different file, and you can like clean up your code certain ways. But at the end of the day, there is a higher investment of just like getting someone on the team, getting them up to speed. If they don't know TypeScript, that's going to be a complication. You're sort of, limiting the pool, or at least like increasing the ramp up time to hire someone new. That kind of doubles up with learning curve. But like, learning curve is like the long-term thing. Cognitive load is just like you're immediately looking at code that is more complicated, that takes like some extra amount of brain power that looking at regular JavaScript wouldn't. But you could also look at it like a vanilla JavaScript function might be a higher cognitive load to actually figure out what it does. So it's, I don't know, maybe that's a horse apiece. But another pro, it's opt-in. So if you want to implement it, you can kind of do it at your whim. Like, you can do it one file at a time. You can do it one function at a time. It's as much or as little as you want. Like I said, if you want to just have TypeScript and write any type for 99% of your code and just type one function, you could do that. That'd be weird, but you could do it. So hopefully that covers some good use cases and some considerations of the cons. Still, in the end, I think most of the time, for most projects, most teams, TypeScript's going to be a big win. Okay, I can get to the how. So if you're brand new to TypeScript or to React in general, highly recommend just creating a new React app. To just, if you're familiar with Create React App, it's just basically like a package that just abstracts all the complicated nonsense associated with scaffolding a project and just builds a React app for you. I'm sure most of you have probably heard of it. But they have a TypeScript specific template, which is pretty cool, and I just wanted to call attention to it. So you can just use this little flag and it will build a Create React app, but using TypeScript, which is kind of neat. For a manual installation or adding to an existing project, just your typical npm install or yarn. I didn't put it on there, I meant to. But yeah, you probably know how to install something with Yarn if you use Yarn. As far as like configs, there's the important thing to note is the TS config. I just like included just a really basic one. There's a ton of properties in here. I didn't want to go over all of them in great depths because a lot of them are really specific to like build configurations, or they're like, if you want to customize how TypeScript treats your code, this is the place to do it.
We have a quick question, Matt.
Yeah, go ahead.
In your estimation, how long does it take to become competent in TypeScript? I think as you're talking about some of these cons.
Good question. Well,
as everyone learns exactly the same, it's 1 hour. No.
Well, some of it depends on your background. Like if you are familiar with with strongly typed or strictly typed languages, like if you're familiar with C#, TypeScript's going to be quick. Like the syntax is almost identical. If you're not, though, like I said, it's opt-in. So if you want to learn TypeScript, like I said, I would recommend firing up Create React App and just like starting super simple. As to like what constitutes competent, I don't know. There are like easier ways to execute the syntax that like may end up being less optimal from a like getting stuff done standpoint, but might be like easy from a I'm just learning this and this is how I know how to do it, so I'm going to do it this way right now kind of standpoint. All I know is like I joined a team. So 2 jobs ago, I joined a team not having ever written any TypeScript in my life, and I was just like, it's fine, I'll figure it out, and I did. So like you could do that. Just like get the basics down. Personally, I feel like knowing the basics is going to get you so far, because like this is a tool that's there for your convenience. There are more complicated ways to implement it, but most of the time you're going to want it to be easy because you want to understand it quickly. You want someone else to look at the code and understand it quickly. That's kind of the point, is like, you know, the sort of in the weeds stuff that I'm going to get into later exists sort of as I'd say most of them are edge cases. Like most of the stuff that you write is going to be one of like 10 different things, and you learn those and then you're good. Like related to learning React, I would say it's a fraction of the time to be competent. Maybe not to be like an expert. I don't know if I would even say I'm a TypeScript expert, but to get competent, it's honestly really quick. I would highly recommend just like looking into it, spend like a couple hours messing around with it, and you could be comfortable with it pretty quickly related to other sort of tools and whatnot. Hopefully that answers the question. All right, so I just wanted to touch on config and stuff. This is going to be really like specific for, you know, different use cases, but you know, basically like you've got compiler options that are all of your preferences. Include is just like what directories are we going to look for TypeScript files in. Allow.js is a property that allows you to like use JavaScript files. I'll explain some of that in a little bit. Sorry, I just had to clear my throat. No implicit any. That's like don't allow you to use any, the any type. Any type means, unsurprisingly, anything. It can be anything. So if you put that all over your app, it's going to kind of be useless. So there's a property that makes TypeScript not allow you to do that. And there's a bunch of stuff like that too. There's like don't allow nullable stuff, or don't, some of it's I'd say it's about half and half, like details about your own personal app configuration, like how are modules resolved, et cetera, et cetera. And then the other half is like personal choices, kind of like you'd set up a linter, for example. I'm not going to go into the Webpack hole because that's a scary place. Just know that you need a specific TypeScript loader for Webpack. Most of the time, you'll just toss this in front of whatever other loaders you have, and it'll be fine. Maybe the source map loader just helps with debugging. There's a bunch of stuff with Webpack, but that's kind of, I feel like, part of a separate talk probably. So we'll leave that there. Yeah, so if you just keep JS files, it just won't parse them. So you can have as much JS or JSX files in your app as you want. TypeScript won't touch them. That'll be fine. So you can opt in one file at a time by just changing the extension to a TypeScript extension, and then suddenly TypeScript will read it. Great. The other thing you can do is you can use these flags. So if you have a JavaScript file you want to check, but you for some reason don't want to change the file extension, you can just put that TS check right at the beginning of the file. Same with a TypeScript file. If you're like sort of in flux with it and you just are tired of getting a bunch of errors, you can just TS no check at the beginning of the file, fix it all up, and then remove it. And then you can by line ignore, if you have a really complicated thing that you either don't know the type of or don't want to fix at this moment, which is a scary hole to go down, but it's there for you. When you're using external packages, third-party packages, you'll want to add type files for them. A lot of the popular ones have TypeScript support, as I mentioned. Usually they're annotated by this like @types prefix, and you'll get all your types neatly in your node modules within the @types directory. But there are packages that don't have types, and you can work around that by declaring this a module and saying this is a module. It doesn't have any types, but please don't yell at me for liking things that don't have support. And you just create a file, a d.ts declaration. I think it stands for declaration something, d.ts file, whatever you want to call it. I just put a wildcard there. Usually if you install a package and it doesn't have type support, that like TypeScript will give you a nice little message that says, try installing this types file. And then you just copy and paste that in your terminal and it'll be there most of the time. And if it's not, you just do this. So it's fairly easy to work around, but if you have a lot of third-party like packages that aren't supported, that might be kind of annoying for your project. I don't know. You can also, in a lot of cases, like declare them yourself, like actually go in and declare the types. But this is a way to just like work around that if you don't feel like doing that or whatever. But yeah, go ahead.
Yeah, another question came in. Does ESLint work for TypeScript 2 in VS Code?
Yeah. There's like there's TSLint, and I feel like this is something that got updated somewhat recently. But yes, there's like specific TypeScript linting. I do not remember all of the configuration details about it right now, but yeah, there's like a TSLint file, and you do similar configurations there as ESLint. I can't remember if like TSLint has now sort of rolled into the ESLint family. I think that's maybe what happened. I just looked this up the other day to like remember this, but yeah, Carrie's giving me a thumbs up. So yeah, I think ESLint now supports TypeScript. So you don't need any like special or different packages. There might be a little bit of difference in the configuration options that you can use and stuff, but yeah, the answer to your question is yes. Sorry for saying so many words.
Well, that's great. Thank you. That's a great question.
Yeah, that is a good one. I meant to touch on that and I forgot, so thank you. So I swear that this had syntax highlighting at some point, but right now it does not appear to, so apologize. But yeah, this is like your basic type interface, just the bare bones, as simple as you can get. You use the type keyword and you create a type. Usually this is formatted in whatever it's called, capital, Pascal case. I'm not thinking too straight right now, Pascal case. And yeah, if you're making a type which is props for a JSX, like a React function, generally the pattern is you say whatever it's for, and then you add props at the end. And these are all your props. So this one just has one prop that's called message, and it is of type string. You can use the interface keyword in place of the word type. So instead of type, you would type interface here. And so you can extend interfaces in a way that you can't with types. That's just a minor difference, a little bit of a confusing one, but generally you'll be fine with types, just using the type keyword. So this is just a basic React function that returns a a div with the message rendered as text, just as sort of a control group. So you can see what that looks like without any TypeScript. So you have some options when it comes to like how you express these functions. So this kind of shows all the different ways that you can do it. This is how you express the props as the type. You add a colon and then you add the type that you added up here. So you're assigning it this type. You don't always have to, I think this might be like a configuration and option in the TS config as to whether or not you have to do this. But the other colon at the end here is what the function returns. So you have like outside of your arguments, you have the colon, and then JSX.element is like your sort of standard type that a React component will return. So that's one you'll want to get familiar with if you want to use TypeScript. This one at the bottom is basically the same thing as this one, except instead of using the type app props, the type is inline. So like it's a little less verbose, but it looks more redundant, and it's kind of a personal choice. You can do it both ways. This, in my opinion, is a little cleaner, and it kind of depends on how many props you have too. Like this looks fine, but if you have a component that has like 15 props in it, and you like type 15 props out here and then a colon and then 15 props with types after it inline, it's going to look really messy, in my opinion. So like if it's like a single 1 or 2 props, just typing them inline is still fairly readable and maintainable. But as soon as you start getting into like bigger, more complicated functions, extracting the type into its own declaration is just a nice, more clean way to read it. Okay, all the types. Now we're going to go through all of them, or at least a nice little list. This is, again, straight from the TypeScript documentation. So if you want to like, refresh yourself on this list, it's right there. But I really liked this because it kind of just like in a nice little list, just sort of goes over a bunch of your basics. So basic types, and I'm sorry, like for anyone who's sort of newer to this stuff, I didn't really explain what types are. I know like type is such a vague word. What does that mean? We use that word for all sorts of stuff, but like understand, if you don't already, that when I'm talking about types, I'm talking about like the types of data in JavaScript, which are like number, string, Boolean, object, and or an array of any of those things. And that's pretty much it. There are more complicated types, but for TypeScript, it's not really the case. So I'll explain that as we're going here. So the top 3 are just like real basic. You've got a string, a number, a Boolean. Any array of a type is going to be that type name followed by the brackets, the array brackets. So that's kind of a unique thing if you're not used to typing. This is, again, the same way it works in at least C#. I don't know about some others, but this is kind of a common pattern for strongly typed languages. Okay, string literals with a union type to join them together. This is basically TypeScript's approach to an enum. There's not, as far as I know, a specific like enum type. This is basically how you do an enum. You have your enum values separated by that separator as union type, they call it, which is just kind of, I guess, TypeScript specific. Some other languages use that too. Like I said, they pull some of the nomenclature from other languages. So I guess it's probably meaningful to be familiar with it. That's a union type.
So
by the way, this doesn't have to be strings. I'm sorry, go ahead.
No, it's okay. So I think Sean may have jumped in and answered, I didn't want to, you were in the middle of a sentence, but does that mean the array can only contain one particular type of data type?
Well, I'm pretty sure you can basically do this with the array type. So you could say, off the top of my head, I don't deal with a lot of data that has arrays with different types. Like 9 times out of 10, it's either going to be an array of strings or an array of objects. But TypeScript is pretty versatile. So like it's entirely possible that you could say, like you could create a type that is string or object, and then you could say it's an array of that thing. Like off the top of my head, I don't know the exact syntax for that, but you could, like I said, you could create a type like this and like, let's say status is string or number. And then you could say names is an array of type status. So that would be a string or a number, an array of those things. So you could do it. You can have multiple data types as an array. Yeah, there you go. You can use it. Yep. You can use a union type, string or number. Yep, just like that. This is actually a lot more powerful than this little example shows, because not only can you use this like or operator, you can use the and operator to add different types together. So like a thing I do and see a lot is like, let's say you are extending some sort of React component, like a button. So you have like your base button props, but then let's say you have like your own button component that has extra props. And you don't want to have to redeclare all the props for the button, but you still want to be able to pass them down to the button. You can just add like your button props, and instead of this or, you would add the ampersand, and then whatever like underlying button props. So you can add props together, you can use or. It's pretty powerful. And that will just like tack on. You can even just do an object. You can just like say, like, let's say you just want to add one property onto an existing, like onto app props. You could just do like type app props, this thing, and just curly brackets with a property and a value. So you can do a lot of different stuff with just these simple operators, and it's really handy. I would never recommend doing this. I don't know why this is even in the docs, but this is just bizarre. Like at this point, if you're just gonna like declare something an object with like no idea what kind of object it is, you might as well just use any. I don't know if any is even on this list, but understand there's one called any. It's a keyword, so it's not like it's not in quotes or anything. I know I've mentioned it a couple times. Again, the second one too, object 2, is also just weird. It says it's preferred. I don't know. I don't know if I would prefer that. That's just my personal opinion. This is really where it's at. So like if you can have nested objects as your in your props. They can nest as deeply as you want. They can be a little difficult to access semantically, but maybe I'll touch on that a little later. Basically, you can't use dot notation. You have to use like property, whatever it's called, where you have brackets and you have like the property name in quotes after the brackets rather than dot notation. Dot notation just doesn't work for whatever reason. Okay, so here you have an array of objects. Here we start to get a little in the weeds. A dictionary object with any number of properties of the same type. So, you know, you may be familiar with this syntax where you have like the index as a key of something. You can do that in Typescript too.
Where you going, babe?
Okay. I'm in a meeting.
Oh yeah, so this one's
Love you, be
similar, but
careful.
it's a syntax we haven't really seen yet, where there's these like carets. What are these brackets called? Whatever they're called. This is something I think I'll go over it a little bit later. It's just a different way of expressing the types inline. Also kind of based off of some other strongly typed languages. I rarely see this one, function. Usually you see it in this syntax here, because it indicates what it returns. So what does this say? Any function as long as you don't invoke it. I don't know how that's useful. I've never seen that syntax, but it's on the docs, so it's good. Yeah, this function that doesn't take or return anything, very common. I would agree, this is very common. Like most of your like state setters in React, you can set as this. It's basically just like, it's a function that does something, but you're not accessing the return value. You're not passing in arguments. As you know, if you've written JavaScript enough, you know, that's a pretty common thing. Function with a named prop. So, all right, so this type, this onChange type, is a function type that accepts a named argument of ID of the type number and returns nothing. This is the same thing as above, except Okay, it's an event. So yeah, React.change event. There's a couple different event types you can use. There's like a focus event for when you focus or blur an element. There's a keyboard event for on key press or on key down. There's, oh, right below it, there's a mouse event. There's a bunch of different events you can use. It's important to know the difference because the different events have different properties. Like the key down event has a key property, which will tell you what key was pressed, but the mouse event doesn't have that. So that's why it's important to know what different types of events you can use. Like a standard event has a target, but not all events have targets. And this is like a key thing when you're sort of building out functionality, like you need to know that you can or can't access those properties all the time. Yeah. And then I don't know why they don't include it, but yeah, like there are functions that return other types as well. All of these return void, but you can also have types that return other types. And this one's pretty important. Last on the list, but really important to be able to have optional types. You don't have to include this type in props. So when you have like a nullable prop, that's, you just put a little question mark there. Solves a lot of problems with very little effort. All right, I wanted to, like, now that I got through that list, I wanted to kind of like refocus here and see how, like, if everyone's kind of good, if everyone like understands what's going on, or if there's confusing things, because basically after this, it all gets real weird.
I love that. Yeah, so does anyone have, I know we've asked a couple of questions along the way, which I love, because that's always great. Sometimes you forget a question, but if you have anything, and remember, this is available on our YouTube channel. So it's React.js Wisconsin YouTube. So that is where all of our events are posted. So if you forget something or want to rewatch something, it'll be up there by tomorrow afternoon. All right, looks like we're good, Matt. Do you need a drink of water or something? Feel free to.
I've been refreshing as necessary. Thank you.
Okay, good.
Okay, well, we can move on to some more complex. Okay, hooks. I don't know. I feel like I throw this in there because this is a React meetup, and I thought it'd be useful to touch on some of the more, like, I feel like people struggle with hooks a lot. At least that's sort of been my experience talking to people and all that. So I thought I'd just like do a quick little bit on TypeScript and hooks. So, and this is where you start to see some of this syntax with the brackets here. This is basically like what the state is going to be in the brackets. And this is the most common syntax you'll see for this. So what it, like IUser is declared somewhere. I should mention, if you see an I, capital I in front of it, that's usually the syntax for an interface versus a type. So with a capital I, that's some interface that's called user. I see someone talking, but is muted. Okay, probably talking to someone else then. All right. This is a similar syntax and also includes a keyword that I haven't gone over yet that wasn't in any other stuff, which is as. So you can basically, like, if IUser is an object type, you can cast an empty object. In fact, you can cast all sorts of stuff. There's another one at the bottom here that I'll go over as well. And the as keyword is a little fundamentally confusing, but basically, like, you're saying that, yeah, this is an empty object, but it's an IUser. It's just an empty one. And so you can use this to get around certain errors that you will get, particularly around like null and empty states. And maybe go in depth a little more on that like later if it's necessary. But yeah, just be aware that like you can cast an empty string to something that's a string type, stuff like that. Well, I don't think you would need to do that, but I'm getting in my own head about this, so let me move on. So similarly, useRef kind of works like useState, except like almost always you will have, well, it depends on how you use references, but a lot of people use refs for various elements, right? You want to like save a ref to an HTML element to do something with that element through React. So most of the time you will be using an HTML element here. You can also use like regular functions as refs and all that other stuff, and you would type it the same way in these brackets to basically say like the thing that's going to be in this ref is an HTML element. You'll also see that it's null by default. So these types are nullable. It's just like a thing that you have to know, I guess. You could also use like this pattern. It wouldn't hurt, but just be aware that this HTML, and you have to know what element you're going to be referencing. So I think you can use HTML element, like just the more generic type, like div inherits from the base. But I think it might depend on your situation, but I think TypeScript might yell at you about that because again, different elements have different properties. And so you have to be a little careful what you're doing, but yeah, that's how you use a ref.
One question is, does the first line set user and set user to null by default with that function arg?
No, it's a good question. TypeScript doesn't set anything. It doesn't do anything to your code because it compiles down to JavaScript. By the time you run this code, there will be no TypeScript in it. That's kind of one of the advantages of it, is it is purely for the improvement of your development experience. It doesn't change your code. Like this one will set it to null because that's part of just the React use state function. This little bit in between, that's the TypeScript. Everything else, if you didn't have any TypeScript in there, it would just be React use state, and then you were setting the initial state to null. TypeScript isn't doing anything. It's just saying that it can be iUser or it can be null. And this is just an alternative to that, where you're not making it null, you're making it an empty object, but TypeScript might say, well, an empty object doesn't have the properties of iUser. And then you say, well, I'm just casting it to it for now. But it's not actually doing anything when you execute the code. It's going to be gone by runtime. What does the null? Okay, yeah. What does null do at the far right? This is just the React use state hook. You set the initial value inside the argument is just the initial value of state. In this case, user. So user is going to be null. So that state, the user state, will be null when you initialize this use state hook. And in this case, it will be an empty object, which is different than null. Okay. So this one, a helper to create a context and provider. Oh, this is, yeah, so this is just an example of someone who is creating a context helper sort of thing. I just kind of threw it in because it had some sort of some of the funny quirks about TypeScript where like, I probably should have, I reordered these slides. This is a generic, I will get into generics in just a second. Basically, it's a generic type where you say, I'm going to create this type. It's going to be something, and it's going to be the same something as this. Let's ignore it for now, and I will get to it. One of the other things I really liked about this one was that it included this as const, which is like weird, but super helpful if you're making your own hooks and you use TypeScript. As const makes TypeScript infer a tuple. A tuple is just only two values in an array, always in the same order. So your use context and your provider in your sort of typical hook, it'll be like use something and then set something. And that's how you can create your own custom hook with your state and your state setter as an array without TypeScript yelling at you. Because if you don't include that, TypeScript's just going to assume it's like just an array of stuff that could be any length, could have and should only have one type in it unless you specify otherwise, which is what you're doing here. You're specifying otherwise. It's really common in custom hooks to do that, which is the main reason I wanted to include it. All right. Generics. Generics are basically a way to just like make sure that whatever type is moving through, I would say it's usually involved with functions. I think that's true in this case. Like that whatever type it is, it remains the same type. It's usually used a lot for like utility type functions where you may be passing data through a function and you're not changing it. You just want to make sure that it stays the same type. Not sure if I'm explaining this very well. So this, I try to like, I really liked this on the TypeScript docs where it's starting out with just like a real easy function where you pass in an argument and it returns that argument back to you. It's just an identity function. So arg is a number and it's going to return a number. That's going to be true. Like with this function, that's going to be true regardless of whether it's a number, a string, a Boolean, an object, an array. It's always going to return what it is because it's literally returning the arg to you. So you could just say any, because anything could return anything. But if this function didn't return the thing that you gave it, any would be right, but your actual output would be wrong. So for that type of situation, a generic type is useful. So whatever type this is, and so this syntax here, like declares the type, and then you have the type as the argument, and then it also returns the type. This word here with capital T is not a keyword. It's not anything special. You could replace it with just the letter T. In fact, in most TypeScript like references, that's how you'll see it. You'll just see, and not even TypeScript, that's true in like other languages as well. You'll just see a capital T. If you see that, that generally means it's going to be a generic type. So whatever type you pass in here, it's going to return that type back to you. So if you pass in a number, you know you'll get a number back. If you pass in a string, you know you'll get a string back, etc. It's generic. It's generic across whatever type you're using at that moment. Hopefully that makes sense, because I feel like generics are something that is difficult to wrap your head around initially when you're trying to like figure things out, especially when you're just reading code for the first time and you're like, what is a capital T? What is that? Also, especially when it's part of another, like it's one type of many, like where there's maybe multiple types in a function and one of them's just a capital T and the other one's a thing that makes sense. So just be aware. I'm hoping that like clears things up here.
And there's a question in the chat. It might just make more sense for you to read it, Matt. It says, so function identity, arg, number, string, return arg is invalid.
Yes, that will be invalid because string is not of the type number. So when you return arg, TypeScript knows that arg is a number type. So it's going to throw an error, like before you compile, like in your IDE, it'll tell you this, arg cannot be assigned type string or something like, I don't remember the exact wording, but yeah, it'll be like, it'll tell you it is invalid and TypeScript will yell at you for it. Looks like I'm just like glancing through the chat. It looks like some people are kind of getting ahead of me already. So I'll just keep, there's more to it here. Oh yeah, you can extend generic types too. So you can say like, whatever type this is, it extends this interface right here. So we have an interface, it's just called lengthwise, and it has a length property. So whatever type is in here is going to have a length property. So the little comment. Yeah, so you know that you can do this because you know that you've extended a type or an interface that has a length property. That I feel like that's kind of a niche little factoid. I don't know that I've really needed to extend a generic type before, but it's nice to know that you can do it. So if you need to access a specific property and TypeScript's yelling at you that like, I don't know for a fact that this type has this property, you can extend an interface that has that property and then TypeScript will know. Key of and type of are super cool and weird and really useful. So we have a type point, and this is just like an XY coordinate. Both of the values are numbers. and you can say type P equals key of point. The keys of point are X and Y. So you know whatever point is, it's going to be one of those two things. This is super useful if, like, most of the time I run into it is like you're trying to access a key as a string, and it thinks that the type is string, so it's not going to let you access the property. So you say, well, no, it's a key of this type. So and because I know it's the key, I know I can use, you can like find this value at the index of this property. So if I was to type like point in brackets, capital P, we know that that index would be in there because it is a key of point. It's going to be X or Y no matter what it is. So you can use that index reference to get the value, which is 9 times out of 10 how I use key of. Let's see. Oh yeah, and this, yeah, a little wacky here. I'm like reading through this like I didn't make the thing, but I did. So let me just remember what's going on here. So a key of arrayish. Oh yeah, so we can say it's going to be a key of this array. We don't know exactly what the keys are. We just know it's going to be a number because everything in there is numbers. So if it's a key of that thing and all of those things are numbers, we know it's going to be a number because it has to be. It's a key of it and all the keys are numbers. This is a little funny. I hope it makes sense to everyone. But yeah, sound off in the comments if it doesn't. All right, so same deal with, this is basically kind of the same thing with objects. So, your objects are going to have keys that nine times out of 10, your object keys are going to be strings. And whatever those strings are, M is going to be one of them. This is string or number, huh? Okay, I confused myself. Okay. I don't know why that's that way. Let's move on and maybe I'll remember. It might have just been like a copy paste mistake or something, but someone can feel free to correct me if I'm wrong there. So, all right, S is hello. It's a string. It's a specific string. N is a type of S. Yeah, I don't know. These are kind of weird. I feel like if you did something like this in a code review, people would be like, what are you doing? So yeah, some of this stuff's weird. And like I said, it gets a little in the weeds, but there are like edge cases where this stuff's useful. Personally, the one at the top here, like where you have an object with a bunch of named keys and you want to access some specific ones, that's most of the time where you're going to find this useful. This stuff is weird. I feel like if you sent this to a code review, I'd be like, this is really confusing. You could probably do this in an easier way. But it's there for whatever specific cases you might need. Oh, this one is important to mention, return type. Again, I don't think I've ever used this in production because it's like, again, cognitive load. Like I have to figure, but basically return type's just the return type of whatever this type is. We know predicate is a function. We know it returns a Boolean. So the return type is going to be a Boolean. But really, just type Boolean. I don't know. Some of this stuff that it exists for specific reasons, and it's good that it exists, but also like I think some of it kind of gets into the territory of making things complicated just for the sake of it. So I want to sort of leer away from that a little bit. Did I okay. Oh, I'm being silly. I'm sorry. I just glanced over the type of. So type of S is not the string hello, it's the type of that variable, which is a string. I'm sorry, I glanced over this and I realized I was only doing key of here. So whatever the type of the variable is, that's what this type is going to be. That actually is pretty useful because like oftentimes you'll know what types you're using, but you won't know what the actual data is going to be. And so having something that is the type of the other thing can be useful. There was one more point I wanted to touch on about that, but I'll get to it if we have time afterwards. Index access type. Oh yeah, this is what I was talking about before, where like you can't use dot notation, but you can use the index of something. So like where you might have like nested types, and you might want to access a nested property of a type. This is a way that you can do that. Like when you have a big body of data and you have a function that only interacts with one piece of that data, but you already have the types all listed above because it's part of the props that you've accepted into the component, then you might use something like this to say, okay, this function is messing around with this number, but it's not. I wouldn't use this for an age. Like I would just type number here. But if you have like an enum, this can be really useful. Like if age was an enum of like 18, 21, 50, then you could like use this, and then you would know that age is either whatever specific steps you're putting in there. Otherwise, you would just use number here. It's not a great example, and I made it, so I'm making fun of myself. I'm sorry. Yeah, but it is something that's, yeah, it's just like dot notation, more or less. Okay, conditional types. Oh yeah, this one's also a little weird. I've said I've written TypeScript for a number of years. I don't think I've ever actually used this, but I did want to go over it because it's in the docs and it might be useful to you. Basically, you can see there's a ternary there, and if dog extends animal, then this type is a number, and if not, it's a string, and just your basic ternary. So yeah, you can put dynamic things in there and then figure out whether or not they match the conditions, and then that will be one type or another. Yeah, I don't know. I haven't used it much, but it exists. Seems kind of wonky to me. Just my opinion. Oh yeah, man, mapped types. All right. So
I wanted to just kind of interject here. It seems like we're having a lot of questions coming in.
Yeah, probably.
And it's about that time, and I know I always like to make sure we kind of stick to where we said we were going to be, and maybe we need you to come back again, Matt. I feel like I feel like people have some really great questions, and so did you want to touch on anything in particular, just kind of as wrapping, as things were wrapping?
No, I mean, so yeah, so I have basically like, I think just one or two more slides.
Okay,
but
perfect.
This is like but this is like, it's also like pretty complicated. It's like, this is probably about as complicated as the stuff gets, as far as just like, hold on, let me see, what do I got? Yeah, all right. Here's what I want to say. If you write this, I am not going to have any idea what you are trying to do, and I've done this for a while. So like, I think, it's a powerful tool, and you can, great power, great responsibility, et cetera, et cetera. You can do a lot of really cool dynamic stuff with TypeScript, but just understand that when you do, it can be really complicated, and complicated to parse. But there are definitely cases where, you can really creatively extend your types with these, like mapped types is a really useful one, template literal types. I think these are the last two I wanted to touch on. They can get pretty weird. Just look at this stuff. If you're not familiar with TypeScript, this probably looks like foreign language to you. Yeah, I mean, we're kind of getting to the end anyway, and I did at least just want to mention them to show you that, like, just some of the neat stuff that you can do. You can access properties. I don't know. Maybe, yeah, if there are questions around it, I can get into it. I did realize we would probably kind of be getting to the end of this around the time I was getting into like the most like weird and complicated stuff. Honestly, if you're really interested in those things, I would recommend going to the TypeScript docs, like taking a good hard look at them, and like like sit and think about them yourself, because I don't know how well I can explain them in like 5 minutes. Really powerful, neat stuff with a lot of possibilities and potential, but not probably something I'm going to be able to impart on everyone in just a few minutes. So I think it's a good place to cut it, and we can like ask some questions and talk about stuff and whatever we want to do.
Okay, sweet. Well, first I just want to say thank you, because I know everyone has been just putting in the comments how like just how useful this has been, and how yeah, the hour went by super fast, and I agree, because it just seemed like there was some killer content here. But before we let Matt get back to his other life, what other questions do we want to throw at him? Does anyone have anything?
Yeah, feel free.
I
Happy to
definitely
answer.
think we should do this again, though. There was a lot of really great questions coming at, kind of that when we got into the weeds, if you will, on the specifics. So.
And I have a question for you.
Shoot.
Okay. There are times when you take advantage of a lack of type. Let's say, for instance, a Boolean test. Something might be a number or characters, and then you just do, does it exist? Is TypeScript going to allow that, or is that going to throw an error?
It will yell at you, and it will say whatever it is, like, can't be coerced to type Boolean. So you have to do like, you either have to include null as a possibility of your type, like this type can be null, or there are some workarounds, but like the short answer is no. Like that sort of null check is going to cause some problems. And yeah, there are workarounds, but yeah, it's one of those things that you could use. Like you could use the any type, like there are quick workarounds like that, or you can actually just add that union type and then add null to it to say, yeah, it could be this thing or it could be null. But definitely like, even if you're using a Boolean actually, and it's like you just use that sort of short circuit operator, and it's null, it's going to yell at you that Boolean can't be null. So it's pretty specific. There are probably configurations in the TS config that you can sort of change that. You can add in like TS ignore for that line if you really don't want to, but TypeScript does want you to like specify that if this thing's going to be null, we should know about it.
And then is there a compile option without bundling, like compiling to a more readable state so you can see the results or resulting JS for the TypeScript you wrote?
Yeah, TypeScript has its own compiler called TSC. You can install it just on your machine. You don't have to use Webpack or any of that other stuff. I mostly covered Webpack because it seems to be like one of the more common, people writing React apps often use Webpack. But yeah, you can look up TSC. It's a standalone TypeScript compiler that you can use.
Awesome. Any other ones?
Yeah, this is more of a question about like the future of TypeScript, because quite frankly, in a dynamic system like React, I kind of don't get the benefit of using types. It's almost like you're putting guardrails over a road that might not be there. And do they have any like future plans to maybe actually have it allow you to do runtime type checking too?
I don't know off the top of my head what are like the future plans of TypeScript at the moment. I'm sure they've got things in the hopper, but I don't necessarily know what their strategies are. I will say, like, you get the best bang for your buck with TypeScript if you, and I meant to mention this in the why section, but like, if you don't have anything for any types, and let's say you also don't have any unit tests or any sort of test suite, nothing, no guardrails, no road cones, no nothing, you're going to get the best bang for your buck. But as you sort of add in other forms of safety, like if you have a robust unit test suite, maybe you use something like GraphQL, which already has a type schema, you're like really quickly going to lose a lot of that value because that value is sort of covered elsewhere. Like if you're already writing unit tests to like for all the different types of your function, like if your function can accept all these different types of data and you are handling it and you are unit testing it to make sure it can handle it, yeah, declaring that type might not be that useful, but I think it kind of depends on the overall architecture of your project. Do you know what I'm saying?
No, that makes a lot of sense, and thank you for that. It seems like the community is definitely going in this direction. I feel like I'm standing in a stream going against it, so that's why I'm here trying to learn more about it and where it
So
can be
for what it's
applied to
worth,
be useful.
sure, sorry, yeah. For what it's worth, my last team decided against using TypeScript because we had those things. We used GraphQL, so we had type safety in that regard, and we had a very robust unit test suite. And so they decided, that TypeScript probably would be overkill to include, and it was already a mature project, so it would have been quite a lot of migration. So I definitely am of the opinion that, like I said in the beginning, not everything is a slam dunk. There are always costs associated. There are always trade-offs. If you have a big project that already has all these boxes checked, you might not need it, and that's fine. It's a tool to be used for who needs it.
Which is funny that you mentioned GraphQL, because I thought GraphQL, I know a project I was considering working on. I believe they had some sort of mechanism where they auto-generate the TypeScript for you.
Yeah, there are some cool GraphQL integrations. Because you know the types from one place to another, they can definitely like automate a bit of that. I guess it depends on how much you want to buy into how useful typing is. I think it's kind of, it's an opinion. Like you said, like JavaScript is pretty sort of ride by the seat of your pants, and some people love that, and some people don't want to be tied down with having to declare all the types of all the different stuff. And like I said, if you're building something on your own greenfield, you don't know what your type's going to look like because you're the one making the data model as you're writing it. Might not be for you. It's probably not for everyone. I totally relate to your sentiment, and I totally understand where you're coming from.
Is there in the community, there seems to be that Flow is like the what do you want to call it, the Facebook approved model to do typing. Is there any preference, or are they moving away from that more towards TypeScript? Just kind of curious.
Not really sure about that. I guess I don't know. I don't know. I don't like follow a bunch of different like big organizations and what they're doing all that closely. I know that's really funny because I'm using React and like they made it. And I mean, they also made like Relay and, didn't they? And people like may or may not use that. I don't think like every choice that every big, company or team makes has to be followed to the letter. And I think it's fine that it doesn't, and that people are sort of free to have a bunch of different options. I'm sorry, I don't know all that much about like the direction all of the things are going in the future. I just kind of keep my head down and write my code, and I like what I like, and I don't like what I don't like. I don't know. Sorry, that's not a very useful answer.
No, I mean, it was just more curiosity than anything. I personally never even looked at Flow when TypeScript's out there. Why would I bother? But
I haven't either.
Kind of curious.
No, TypeScript's really the only one I've touched as far as like typing in JavaScript. What I will say is like I was doing a little bit of research for this talk, and I noticed there was the state of JavaScript like study or whatever not study, but it's like a poll or whatever they do every year. And basically TypeScript is just blowing everything else away. It's something like 75%, and everything else has like 6% tops of, like what developers are using, what they like, etc. I guess I'm just lucky to have stumbled into learning TypeScript a number of years ago and never really looked back since.
Yeah, ditto. They kind of killed CoffeeScript and similar products, that's for sure.
ClojureScript is another one that I remember. Yeah, there's a handful of them.
Awesome. Well, thank you so much, Matt, for this. I definitely think we need to talk about doing like TypeScript 2.0 or something. because I feel like there's still a lot of questions and a lot of people would appreciate that. But I send you a big round of applause from here in Montana, and thank you to everyone for joining us tonight. Like I mentioned, and I think I put it in the chat, the link to our YouTube channel. So this will be loaded by tomorrow afternoon. And so if you have any questions or want to share it with anyone on your team, if you're trying to talk people in or out of things, I always feel like what we learn here has really helped a lot of teams kind of direct or make their arguments for why or why not. But thank you so much, man. I hope you had fun. This is awesome.
Yeah, that was good. It was nice. I yeah, definitely started getting a little off at the end because I'm like, man, this stuff kind of gets a little weird and I don't use it that much. So I'm glad we ran out of time.
No,
No, hopefully, like, I really think the bread and butter, you get the bread and butter down, and that sort of like the weird stuff, the template literals, the map types, like once you're comfortable with that stuff, it'll make sense when you need to use it, I think. Even some of the stuff I went over at the end, like the key of and type of, as long as you kind of keep that stuff in mind that it exists, and then you're like running into this error and you're like, how do I fix this error? Oh yeah, there's this one weird little thing that I haven't used all that much that just will click.
Yeah.
And that's when that stuff's really great to have around.
Fun. Well, thank you so much again. And thank you everyone for joining us. This is a great turnout. And we will see you next month.
What's going on?
Cool. Sounds
All
good.
right.
Thank you, everyone.
Yeah, take care. Thanks, Nat. See you.